Hi, welcome to EmbVerse. This is Shaunak. Today I am going to talk about the recent blog that I have written at EmbVerse. It is about Modbus RTU Functions subset implementation on Texas Instruments Stellaris Launchpad. So this is the development kit from Texas Instruments, which is known as Stellaris Launchpad. It is having LM4F120H5QR ARM Cortex-M microcontroller. If you click here, then you get redirected to the resources where you have to choose the Stellaris Ware and Code Composer Studio for the Stellaris Launchpad. You have to download it from here. So there you will get the resources. For programming the development kit, you will need to get the LM Flash Programmer. You will get it from here. So basically, I have already written a blog regarding the same project or over Cypress PSOC that I would like to share. So this had already been done. Uh, Actually, I have written a generic Modbus subset function library that implements 8 Modbus functions, Modbus RTU functions to be specific. And I was checking the entire system through a software called qModbus. So here I have used the same generic Modbus RTU C library that I have created, but for a different microcontroller. So I just wanted to verify that it is really working or not. I mean, it is really generic or not. And I was amazed to see that it is completely working fine. So that is how I created this blog and also shared the code, the entire project for the Code Composer Studio uh, of Texas Instruments in my blog. So here, as you can see, I have implemented 8 functions, just like I did it in PSOC 5. So the entire philosophy of the library is going to be the same. You can download the qModbus tool, which is going to be used for the testing purpose from here, which is a sourceforge.net link. It is supporting Windows operating system. So I have also shared a document for understanding the Modbus RTU structure and everything. So it is a very descriptive document that you can go through anytime to understand how Modbus works. Also, there is a wiki link I have shared, so that will also give you a brief overview regarding Modbus. So now I will give you the hands-on session with the code itself. So let's go to the code first. So while it's getting loaded, I would like to give you a brief introduction to the board. You have to connect your USB here, and this is a micro USB port. So you will need a USB to micro USB converter cable with you. This is the reset button for the board. This is the power button. So now our code is here lying over here. You will simply download it. So I will make it save as. and I will save somewhere base temp somewhere here, right? So now it is, we have got the code. So now we'll minimize it. We'll simply go to the folder itself. We will extract it. It's a zip file basically, project zip file. So now we have got the folder. So now you have to open the Code Composer Studio. Make it sure it is version 5. So now as you can see, it is the same folder that is I'm going to use as a workspace. Make it sure it's Code Composer Studio version 5, because the later versions do not support this particular board. So now you have to go in the import project, search directory, and finish. You will need to import existing CCS Eclipse project from here. Go for the select search directory and click the browse button. You have to install Stellaris in your PC. It is already available in the links that I shared with the resources part. So you will have Stellaris installed in C drive. There is a folder called Stellaris in the C drive. Go there. There is one more folder under that is called driver lib. Just click it and press OK. From these two folders, you have to select CM4F because our controller is Cortex M4, and that is why we have to select CM4F and press finish. So now we are ready to build the code. So we will simply right click it and build it. When you are building it the very first time, it will take a little bit more time. In the meanwhile, I will give you a quick overview to the LM Flash programmer that we are going to use. So here, as you can see in the configuration part, you need to select Stellaris development board. In the program part, you have to select the file that you want to dump in. It's normally a bin file. So we will go through here in the debug section, and we got the bin file that we will dump. Then just press the calculate CRC checksum button. It's not mandatory, just for the sake of formality. So now I have not connected my Stellaris board yet. So I will go to the device manager. So as you can see, I do not have any COM port connected yet. So I will simply connect it to my PC. And now, as you can see, I have a COM port 2 for my Stellaris virtual serial port. So now I can program this device. So it's verified complete and passed. That means it is programmed now. Now we will go to the qModbus. The baud rate as of now is 115200. If you can recollect, for the PSOC 5 we used the baud rate 9600. I wanted to go further. So here I used 115200 baud rate. Serial port is selected as Stellaris virtual serial port COM2. And we will simply check out all the functions. So let's see The maximum count is going to be 64. So it is giving us the default values are FF. Read holding registers. So I have set the default values as BBEE. So they are coming as you can see. For input registers, I have set AA55. All these are default values. Now we will write a single coil. So let's say we are writing the coil number 32 and we will put a data as 0 over there and send. So we got the response, that means it is written. If we read that coil again with 8 number of coils to be proceeded, we will get 7F. That means it is written correctly. Now once we power once we reset the board, power reset the board, we will check the EEPROM part. So it should be 7F when we read at that time once again. So now we are going to write the single register, which is a holding register. Again we can write 32 number. 254 is going to be the value for us. So which makes FE 0xFE. So now if we read that register, you can see 00FE. So now it is written correctly. We will write the multiple coils as well. So let's say from 35 or maybe we can say 36, we are going to write 4 coils. And we will read them from 32 to 8. Basically, I am trying to understand that whether it is being written properly or not. As you can see, the first one is going to be 7 because the first bit is going to be 0 as we written, and all the 4 bits are going to be 0 because 36 to 39 are 0. So it is being written correctly. And the last one, write multiple registers, that means multiple holding registers. We can make something like 33. We can write 2 registers. Let's say one value is 0 and the other one is 253. So we will verify once again. So now it is correct. As we can see, FD is going to be 253 and this is 0. So we have used all the functions and they are working correctly. Now we are going to reset the power to the board. Basically we will reconnect the board to the PC. So let's go to the device manager once again. First of all we will close this qModbus. And then we will remove the development kit. We will replug it. So now once again we will check whether the coils are being read properly or not. So we'll go with the 32. From 32 we are going to read 8 coils. It has to be 70, which is correct. Here we are going to be read holding registers. 32 to 3 registers we will read. As you can see, FE00 and FD. So all values are being retained by the EEPROM. So everything is working correct. We have the error exceptions in the code as we had set in the piece of 5 as well. So let's say we are going to read discrete inputs. We go with the start address 32 and we want to read 33 inputs. So basically this sum should not exceed 64. which is exceeding as of now, so it should be throwing an error exception. Yes, it is throwing, as you can see. Also, one more thing. So basically the summation of these two values should not exceed 64 in any case as per my program. Now I would like you to have a look at my library, Modbus RTU library. As you can see, all the four basic elements, number of coils, number of discrete inputs, input resistors and holding resistors are 64. And based on them, I have set up my arrays and variables. You can increase this number as per requirement and also as per your memory capability of the controller. So I think there is fair enough that I had described all these things over here. And for getting more details, if you are if I would like you to test this out. And if you get stuck up somewhere, you can write me at philomath@embverse.com. I will revert you as soon as possible. Thank you.